In 2006, a company made a quiet decision. No press release, no announcement, no fanfare. Just a small team, a new piece of software, and an idea that almost nobody took seriously. That decision, made in a mid-sized office in Santa Clara, would eventually reshape medicine, warfare, art, science, and the entire global economy. So here's the question nobody seems to be asking. How does a company that started making video game graphics end up controlling the most critical technology infrastructure on the planet? Everything you just saw, all of it, runs on the same hardware. Hardware built by one company that most people walked right past for 30 years. This is the story of NVIDIA. And it is far stranger and far more deliberate than you think. NVIDIA, founded in 1993. 3 engineers with a bold and simple idea. Make computers display graphics faster, smoother, and better than anything before. That was the mission. Make games look incredible. Serve the gaming market. Build the best graphics cards in the world. And for a long time, that's exactly what they did. But fate had a much bigger plan for their technology. The mid-1990s were a chaotic, electric time in Silicon Valley. New companies launched every week. Most failed within months. NVIDIA very nearly became one of those failures. Their first product had serious problems. Early reviews were rough. A competitor was already pulling ahead. Jensen Huang, the co-founder and CEO, made a decision that would define the company forever. He didn't cut corners. He didn't panic. He bet the entire company on something better. NVIDIA shelved their struggling product and redirected everything into a completely new architecture. It was a high-stakes gamble. It almost wiped them out, but it worked. In 1999, NVIDIA launched the GeForce 256 and called it the world's first GPU, a graphics processing unit. The gaming world took notice. The industry was transformed overnight. When everyone else was sprinting, NVIDIA was building. Here's where the story gets interesting, and honestly, a little unexpected. A GPU is designed to do one thing very well: process enormous amounts of data in parallel. Thousands of calculations happening simultaneously. For games, that means rendering pixels, but for scientists and researchers, it meant something entirely different. In the mid-2000s, a handful of researchers began experimenting. They noticed that the raw parallel processing power of GPUs could be used for something far beyond video games. They could use it to run complex mathematical models, scientific simulations, and eventually neural networks, the building blocks of artificial intelligence. NVIDIA didn't design their chip for this. But they were smart enough to see what was happening. In 2006, they launched CUDA, a platform that let developers program GPUs for general computing, not just graphics. It was a quiet release. No massive fanfare, but it was one of the most consequential product decisions in modern technology history. CUDA didn't just open a door, it built the road that led to it. Fast forward to 2012. Toronto, Canada. A research lab at the University of Toronto. A team led by computer scientist Geoffrey Hinton entered an annual AI image recognition competition. Their model was trained using, you guessed it, NVIDIA GPUs. The results were staggering. Their system, called AlexNet, didn't just win the competition, it crushed the competition by a margin that left the entire AI research community speechless. That moment, right there, is considered by many to be the starting gun of the modern AI era. And NVIDIA's hardware was at the center of it. After 2012, AI research exploded. Universities, startups, and tech giants around the world began racing to build smarter systems. And every single one of them needed GPUs to do it, which meant every single one of them needed NVIDIA. NVIDIA didn't chase the AI revolution. The AI revolution came to them. The years between 2012 and 2020 were a slow burn. AI was advancing. Researchers were making breakthroughs, but most of the world wasn't paying attention yet. Then came the models that changed everything. Large language models, generative AI, systems that could write, draw, compose music, and hold a conversation. Suddenly, AI wasn't just a research topic, it was a product, a business, a cultural moment. And the demand for NVIDIA's chips went from significant to absolutely extraordinary. Companies that had never thought about GPU hardware were now scrambling to get their hands on NVIDIA's latest chips. The waiting lists grew long, the prices climbed. The demand never seemed to slow down. Every major cloud provider, every AI startup, every tech giant. They were all building enormous data centers filled with NVIDIA hardware, because without it, their AI systems simply couldn't run. The world's most valuable resource was no longer oil, it was compute. Let's talk about why NVIDIA's lead is so difficult to challenge. Because it isn't just about hardware, it never really was. Remember CUDA? That developer platform launched back in 2006. In the years since, an entire ecosystem has been built on top of it. Libraries, frameworks, tools. A generation of AI researchers and engineers who learned to build using CUDA. Switching away from NVIDIA isn't just a matter of buying different chips. It means rewriting code, retraining teams, rebuilding workflows that took years to develop. NVIDIA didn't just win the hardware race. They won the software ecosystem race, and that is a far more powerful kind of advantage. Jensen Huang often talks about the company's long-term thinking, about building platforms, not just products. This is what that looks like in practice. 18 years of patient investment in a developer ecosystem, now forming an almost unbreakable moat around the company. The best competitive advantage isn't the product you sell, it's the world you build around it. So what does all of this actually mean for the rest of us? For people who will never buy a GPU or write a single line of code, more than you might think. Doctors are using AI systems, running on hardware like NVIDIA's, to detect diseases earlier and more accurately than ever before. Researchers are using AI to model climate patterns, discover new materials, and accelerate drug development. Farmers are using AI-powered tools to optimize harvests and reduce waste. Teachers are beginning to access AI tutoring systems that personalize learning for individual students. Artists, writers, and musicians are exploring tools that expand what's creatively possible. All of this runs on infrastructure that NVIDIA helped build and continues to power. The chip that started in gaming is now quietly woven into some of the most important work happening on the planet. Technology is most powerful when it becomes invisible and still changes everything. Now, and this is important, none of this means the story is without complexity. The concentration of so much critical AI infrastructure in the hands of one company raises real questions. Questions about supply chain fragility. Questions about access, who gets the chips and who doesn't. Questions about what happens when a single company has this much influence over the pace and direction of technological progress. Competitors are working hard to close the gap. AMD, Intel, and well-funded startups are all investing heavily in AI chip development. Governments around the world are thinking carefully about semiconductor supply chains and strategic independence. And then there are the broader questions around AI itself. How do we ensure these powerful systems are used responsibly? How do we share the benefits widely rather than narrowly? How do we navigate a world that is changing faster than our institutions can adapt? These are hard questions, genuinely hard. And the honest answer is, we don't have all of them figured out yet, but they are the right questions to be asking. The measure of a technology is not just what it can do, but what we choose to do with it. There's something quietly remarkable about NVIDIA's story, beyond the business headlines and the stock price. It's a story about patience, about building something deeply, carefully over decades, while the world was looking elsewhere. Jensen Huang didn't know in 1999 that his graphics chip would one day help train artificial minds. Nobody did, but the team kept investing, kept building, kept asking, what else can this become? That kind of long-term thinking is rare. In business, in careers, in life, we live in a world that rewards urgency, that prizes quick results, that sometimes mistakes speed for progress. NVIDIA's story is a reminder that the deepest advantages are often built slowly, quietly, and without much fanfare. That curiosity, real, sustained, honest curiosity, is one of the most powerful forces in the world. And perhaps most importantly, that the technologies we build are only as valuable as the intention we bring to them. The hardware is neutral. What matters is what we build with it and why. The future belongs to those who build it with patience, with purpose, and with care. We are living through one of the most significant technological transitions in human history, and it is moving fast. Faster than most of us fully appreciate. The systems being built right now, trained on hardware inside vast, humming data centers, will shape medicine, education, science, and daily life in ways that are still difficult to imagine. NVIDIA, a company that started by making video games look beautiful, now sits at the center of all of it. Not by accident, not by luck. By decades of genuine innovation, strategic patience, and a willingness to keep asking what's next. The question for all of us, for researchers, for builders, for citizens, for curious minds everywhere, is the same question NVIDIA faced every time the world changed around them. What will you build with what you have? What problem, hiding in plain sight, are you uniquely positioned to solve? What ordinary tool in your hands might, with patience and vision, become something extraordinary? The AI age is not something happening to us. It is something being built by people, with choices, one decision at a time. And if history has taught us anything, it's this. The quietest moves sometimes make the loudest impact. If you found this story fascinating, subscribe to Hidden Empires, where we uncover the companies, decisions, and ideas quietly reshaping our world. We'll see you in the next one.